Hey guys, so today for lesson 3, we're going to be learning to use symbolic representation to create equations and solve a word problem. A lot of big words, a lot of kind of intimidating words. Don't be intimidated. You guys have been using symbolic representation to create equations since the first day you saw a word problem. You do it all the time. You make a choice of whether things are addition, subtraction, multiplication, division. You've done that. You should have done it since grade 3. I know you guys feel comfortable with it. Now all that's changed is that there's 2 operations and a missing number that we need to solve. And that one's easy because you just place a letter for that missing number. It's really important before we go into the problem solving framework and solving a number to understand an equation. And I know you guys went over that in beginning, but it's important to, so we know that the letter is the variable. So when we talk about variable, that's the number, 1, that we don't know, or 2, that it can change. So if, for example, I'm going to earn money and I earn $2 a day, and I want to know how much money I'll make in 6 days or 10 days or 11 days. What the variable is the amount of days. That can change. My $2 doesn't change. It stays the same. So that variable is the number that changes. The number that is connected to our variable, we call a coefficient. It's really important to be able to recognize when the coefficient, because it's very directly related to the variable. Okay, this number here and this number in blue, those are our constants. That can't change. Okay, and so now that you know these, and then obviously you know our operation. Subtraction here would be multiplication, and then our equal sign. We're going to dive a little bit deeper into these names to understand a word problem, okay? So now that coefficient is directly related to variable. The variable is the number that changes, and our 2 numbers are the ones that never change. So let's go into a word problem and look that up. Okay, so first step is problem solving, define the problem. Well, let's read the problem first. Belleville Bike Shop rents bikes for $10 plus $4 per hour. Karen paid $30 to rent a bike. How many hours did she rent the bike for? So first step, what's the problem? Well, we need to know how many hours she rented the bike. So I'm going to highlight that in blue. There we go. Sorry. Okay, so I know that it's in blue. Okay, and what is the information that we have? This is where we start to develop our equation. So we know that the bike shop rents bikes. I'm going to highlight the rents the bikes part for $10. Okay, and what else do we know? Plus $4. Oh, sorry. Reverse that. Sorry, rents bikes for $10 and then plus $4 per hour. Okay. We also know that Karen paid $30 to rent a bike. Okay, what I don't know is how many hours she rented it for. So now going back, okay, so our coefficient, variable, and our constant. I'm going to first find our variable. What is our variable? Well, it's the hours that she rented the bike for. We don't know that. So that's the one we don't know. That's the one that can change. Okay, so we are going to do that first. So get my trusty little pen here. I wish there was an option of black, but there isn't. So I know that she rents for an X amount of hours. Okay, do we know the number? Do we have the number that is directly correlated to the amount of hours? Is it what she rents the bike for, the 10? Is it the 30? No, that's what she paid in total. It's the $4 per hour. So the 4 is directly related to our variable, and it's multiplied because it's the 4 is times how many hours. And now we need to find our constants. So what's our constants? We know that no matter how many hours that she's ridden the bike, she's going to pay $10 up front. That's added to the cost. Okay, so I'm going to add 10. And then in total, she paid $30. Now we can begin to solve our thing. But we should really now go to our tools and strategies. or you could have done tools and strategies before solving the equation or creating the equation. So now you would create a tools and strategy chart. Sorry, where's my green? Okay. Just going to do a little one up here. So tools and then strategies. So tools, I'm just gonna put letters just so I'm gonna calculator and other problem solving framework. Okay, so I'm just gonna put a P there. If you could, I'm kind of blanking out strategies, adding, multiplying. Oh, I also, for tools, I also used the graphic model from the thing above, this guy right here. Strategies, I'm having a blank. Sorry, guys. We'll talk about this at the lesson. So now that I've done my tools and strategies, I'm now going to apply my tools. So I have my equation. Now I need to solve. Okay, so go back to my colors. Okay, so we have a positive 10. So I'm going to do the opposite. So negative 10, and that equals 0. That zeros those out. And then whatever I do to the one side, you have to do to the next. Okay, so now we have 10, which equals 20. Okay. Okay, so now I'm going to continue my equation over here. So 4n equals 20. Okay, so my next stage, what's next is my multiplication. Well, what's the opposite of multiplication? It's division. Okay, so if I divide 4 there, that crosses those out. And now I divide this by 4. And then, so now I'm just going to put this over here to give myself room to write. So n equals 20 divided by 4 is 5. I'm going to do a text box to answer my question. So Karen rented the bike for 5 hours. Okay, does my answer make sense? Yes, I think it does. And communicate my solution, I've communicated it. So I'm just going to highlight that in orange. Done. Okay. Hopefully this makes a little more sense, but I will also meet you guys on Thursday to go over it if it doesn't.